And also the last example here on this page I want to take for the formula derivation is find the derivative of y equals to secant inverse x. Okay, so to find out that, what we do as usual, we do y equals to secant inverse x. This implies if you multiply or if you take secant on both sides, you'll get secant y equals to x, right? Now we do differentiate. If you differentiate, you will get d over dx secant y equals to dx over dx. I'm differentiating both sides, right? Now see, for the secant, the y and x, they don't match. So if you do that, the derivative formula will be secant y times the tangent y times the y prime equals to 1. Now what I want to do next is I want to divide by secant y times tangent y, secant y times tangent y. Okay, so and then that thing will cancel out. So what you get is y prime equals to 1 over secant y times the tangent y. So you see that one of the interesting thing here is, what is y? Y equals to secant inverse x, right? Y equals to secant inverse x. When y is secant inverse x, you see that one, then what is the value of y? Y will be between 0 and pi. You see that when y is secant inverse x, the value of y will be between 0 and pi. These are the values of y between 0 and pi, right? So between 0 and pi, right? So that's what the value of secant inverse, when y is secant inverse x, that's where the value of y will be. So in this case, between 0 and pi, what do you see there is, see, if the y falls in the first quadrant, okay, this is the first quadrant, this is the second quadrant, this is the third quadrant, this is the fourth quadrant, right? If y falls in the first quadrant, then both secant y and tangent y will be positive, right? If y falls in the second quadrant, both secant y and tangent y will be negative. So in this case, you will get both of these are either positive or negative, right? So basically the y prime will be positive. The y prime will be positive there. Okay, so let me write one more step here, and then you will see what to write for those secant y and tangent y. For secant y, there is x, right? For tangent y, I want to do exactly the same thing. What did you get from here? The secant square y here, secant square y is basically, what do you get? By the way, I will do this again. Okay, look at here. For secant y, you can plug in x, but we will plug in absolute value of x. We will see why we do that. Okay, but what is tangent y? Let me write down that secant square y minus tangent square y equals to 1. So what I want to do here is I want to subtract 1, okay, and then add tangent inverse x, tangent inverse y plus tangent inverse y. So what do you get? You cancel that 1 and 1, you cancel that tangent square y and tangent square y. Basically you will get this. You will get secant square y minus 1 equals to tangent square y. So what is tangent y? Then tangent y will be under the root secant square y minus 1. That's what you will get. Tangent y will be secant square y minus 1. Okay, so you can write plus and minus there, but the product of these two must be positive. Okay, because you see that when y equals secant inverse x, the y falls in the first and second quadrant, right? Because the range is that. So if it is in the first quadrant, everything will be positive. If it is in the second quadrant, both secant and tangent will be negative here. In that way, the whole thing will be positive, right? So you can write plus and minus here. Okay, you can write plus and minus here. But what you need here is y prime will be the y prime will be positive, because secant and tangent will be either both positive or both negative, because y is secant inverse x and from these range values. Okay, so what I'm going to do here is basically I'm going to write this way. So I want to write 1 over secant y times, and then there will be like plus minus under the root secant square y minus 1. Okay, so instead of writing both plus and minus, I want to do one thing. The reason here is the product of these two must be positive, right? Either you take secant y is negative and that thing as negative, and then or secant y is positive and that thing at positive. So instead of writing that, I want to use x. So instead of writing that plus and minus, I want to write this way. In that way, both the product will be positive. For secant y, I want to write mod x, and then under that, I want to write what is the secant y? It is x and then square minus 1. You see that? So y prime, in that way, for any values of x, you will get positive values. Just the mod, the absolute value I use to make sure that we get positive, because the root is always positive, right? Instead of plus minus and secant y, I want to write absolute value of x. So that, because secant y is x, so I want to use absolute value just to make sure that I get positive values in the product, in the denominator. You see that? So same concept, if you use that for the cosecant inverse x, you will get the same value but the negative sign. You will get negative 1 over mod x, and then under the root x square minus 1. So this is the formula for cosecant inverse x and the secant inverse x. Okay. So you see that these are all the 6 formula we derived, 3 of them, and we wrote the similar steps. We can get the for the next 3 by using the similar steps. So these formula, look at this. So we are finding d over dx sine inverse x, right? D over dx cosine inverse x. You see that matches? If they match, then those are the formula. But sometimes, look at this, d sine inverse u over dx. If they don't match, we write exactly the same formula for sine inverse x, for sine inverse u, and then the extra thing you do is u prime, because they don't match, right? So the derivative of sine inverse u with respect to x will be 1 over under the root 1 minus u square times the u prime. The u prime is for not matching u and x. Here we didn't have u prime because they were matching, right? Because you were finding d sine inverse x over dx. You were finding that one here. They were matching. That's why we didn't do u prime there, right? You could do x prime. X prime is 1 basically. Similarly for cosine inverse u, for the cosine inverse, the formula is negative 1 over under the root 1 minus u square, right? And then since they don't match, again this is u prime. For tangent inverse, 1 over 1 plus u square times u prime. So this will be negative 1 over 1 plus u square times u prime. This will be 1 over absolute value of u under the root u square minus 1, and then times u prime. I'm using the exactly, I'm just replacing x by u there, right? And then negative 1 over absolute value of u under the root u square minus 1 times the u prime. So these are the formula. Okay, so we will be using this formula to solve, to find out the derivative of any inverse trig functions. Let's look at this one. You want to find out y prime when y is equals to sine inverse x square. If it was sine inverse x, then the derivative will be 1 over under the root 1 minus x square. But there is x square there. Instead of x, there is x square. So what we do is we assume that as u, right? So basically, I want to find out the derivative, differentiate. So it will be dy over dx is equals to d sine inverse x square. I can write sine inverse u because I assume that as u, right? Let me write down sine inverse u. So d sine inverse u over dx, right? Because there is dx there. So d sine inverse u over dx. But look at that. If there is sine inverse u over dx, then the formula will be 1 over under the root 1 minus u square times there is u prime. Okay. So what is the value of u? U is x square. So I am writing this as, so 1 over, right? 1 over 1 minus u square is how much? U is x square. So that will be x to the 4th, right? Because square of x square is x to the 4th times the 2x. You see that? So what is the final answer? Final answer will be 2x over under the root 1 minus x to the 4th. That is the final answer. Okay, so we will see some more examples here. Okay guys.